We are an official PASS organization. We have new websites and everything, so please log on and take control of your login and see all the opportunities with PASS. PASS has quite a large number of virtual chapters. You would take your PASS login and associate it with the other chapter, and then you'll get the email announcements about their meetings. SQL Saturdays are one-day mini conferences, and they're held throughout the world. These are a great item for having a conference in your area. They have limited expenses, usually just to cover the luncheon, and now some of the SQL Saturdays have pre-conference classes going on. So you can also join a local chapter. You just go out to your PASS login and see what's available in your area. There's many volunteering opportunities with PASS. And if you've discovered us through YouTube, we would love it if you could become a member on the SQL PASS. And here's the LinkedIn, Facebook, Twitter, and just the PASS account in general. It's a free membership. The membership information is kept confidential, and you only receive emails about meetings. Today's lecture, our presenter is Mike Bird. He's a former rocket scientist and USAF, the Air Force flight fighter test pilot. He's now a SQL Server geek. Past opportunities included freelance technical writing for the PC Magazine, senior software manager for a government-sponsored munitions effectiveness committee, and an IT director for the Texas Windstorm Insurance Association for 9 years. Currently in SQL Server 2016 RC3, 2014, 2012, 2008 R2, and 2005. Goodness. He's presented at many SQL Saturdays in Austin, Baton Rouge, Denver, Dallas, Houston, Oklahoma City, South Florida, Gothenburg, Sweden, Atlanta Business Intelligence Group, the Albuquerque, Tampa, Jacksonville, Atlanta, Gothenburg, and Sweden again, and Oslo, Norway. And I think he just mentioned he did Sydney, Australia. Currently, he's consulting for several Austin-based software companies and a freelance writing a series of performance articles for SolarWinds. He's also working up a new data architecture and implementation plan for the Daughters of Republic of Texas system. So Mike, I'm going to change the present and make you the presenter. And you should be able to share your screen. Yes, I see your opening slide deck. Thanks, Mike.
Okay, good morning or afternoon to everybody out there. This is the first time I've done a webinar. I've done, as you know, as you could tell, many SQL Saturdays. I just have always been nervous about webinars because of not being able to see the audience and getting reactions back. I don't know if I put you to sleep or not. Okay, I live in Central Texas. You look in that right-hand picture, that's what I see out my kitchen window every morning. It's a hard life, but somebody has to pay the property taxes. I live just about an hour west of Austin, and Austin is in the triangle between San Antonio, Dallas, and Houston. She's already read my bio, don't need to go through that. I don't know if you heard Shania Twain just then, but she is thanking me for being a rocket scientist. I've been a sports car driver, Air Force fighter pilot, now I'm a SQL Server geek. And my whole life's been about performance, and performance is what I love to do, and that's why I still work. Today we're going to talk about indexes. What are they? We're going to talk about clustered indexes, non-clustered, index performance, missing indexes, index utilization, index performance or non-performance. Have lots of demos, and the PowerPoint and demo scripts are available if you email me. And remind me at the end, I'll put up my email address again. My goal is that everyone, including myself, will have a clear understanding of indexes, when not to use them, when to use them, and how to use them. So let's look at index basics. Okay, what we're not going to talk about today are filtered index, index views, XML indexes, spatial indexes, column store indexes, or memory optimized indexes, although I have a briefing at the end that I'll talk about where we're not going to talk about today, memory optimized indexes, but I have another briefing on that. So why do we have indexes? Well, what is the purpose of a database? The database is to try to get data back out for presentation to someone. Indexes help speed up that query performance to get the data out. It's really sort of, you think of as a shortcut to access specified data. But as in the real world, there's no free lunch. It hurts any data modification language performance, and that means inserts, updates, or deletes. It also takes up indexes take up additional disk space. And sometimes they can actually hurt performance when you have bad statistics or the index itself is not selective enough. We'll talk about all that in a little bit, especially in the demos. Okay, so I first need to get some definitions out of the way. We have a heap, which is an unordered collection of data. A heap is just a set of data, but there's no way to address a particular row within that set of data. However, under the cover, SQL Server maintains its own primary key to uniquely identify each row. It's just not seen or addressable. I personally don't use heaps unless it's a small temporary result set, like maybe an attempt table. In my mind, almost all tables should have a primary key. And just keep this in the back of your mind, because I'll talk about it several times. The index wizard thinks all tables are heaps. So what is a primary key? Most of the time, not all the time, but most of the time, a primary key also defines the clustered index, and we'll show that in the following demo. It can be one or more keys or columns, and it allows SQL Server to uniquely identify a specific row. That's what the definition of a primary key is. In other words, a unique combination of those one or more columns that are uniquely identifies the specific row. Data is normally retrieved in order by that key. However, parallel retrieval may result in unknown order, and that's why Microsoft does not guarantee in a result set the order unless you put in an order by clause. You can think of the table of contents in a book. Everything's ordered by the page numbers, and so if you're thinking that with that analogy, you think that, well, pages are then the primary key. In other words, you can address each page by its number. Clustered indexes. Normally, your primary key is your clustered index, but you can define them separate, and I'll show you a demo of that in a few seconds also. It defines the order data is stored in SQL Server. It's not necessarily how it's stored on the hard drive, it's just how SQL Server stores it in its storage system. Again, a clustered index can be one or more columns. Usually the primary key and the clustered index are the same. I'll show you examples of that. And the default definition of a primary key also creates a clustered index with the same name. I'll show you that too. A clustered index contains all the columns and rows in a table. In other words, it is the table itself. And because it is the table itself, you can only have one clustered index per table. When you create a clustered index, you need approximately 120% of the total table size to create it, just so it has some working space to do that. And I just want to point this out. There's a continuing architecture discussion about what column types to choose for clustered indexes. In Austin, at our Austin users group meetings, we had Joe Seco, and Joe and I have very sometimes substantial discussions on natural keys versus artificial keys for clustered index. Anyway, the definition of your clustered index may affect performance. I'm not going to really get into that, but it's just something that's going on and still continuing to go on. Okay, non-clustered indexes. What is a non-clustered index? It's sort of a subset of your clustered index. Again, you can pick one or more columns of the keys. They don't have to be unique though. Data is retrieved in order by that key. All rows are stored, but only a subset of the table columns are stored unless filtered. Why? What does this do? Well, it makes a non-clustered index makes it narrower in width, and so you can fit more data on a page, and that means less I/O. Microsoft says you can have up to 999 non-clustered indexes per table with 2008 and above, and 2005, 249. Why anybody would have that many is beyond me. Not even for a data warehouse can I imagine having that much. But anyway, you could think of a non-clustered index as sort of like an index in a book. It's pointers to a specific set of rows or the page numbers in the book. For example, if you went to the index of the book and you looked up my name, Bird, B-Y-R-D, then it might say it's on pages 5, 10, and 15. So now you don't have to go through 1, 2, 3, 4, 5. You can go directly to page 5, page 10, and page 15. And that's sort of how you can think of a non-clustered index. It gives you pointers to a select set of data. Non-clustered indexes do, however, contain the clustered index key, so there's no need to put the clustered index key in the non-clustered index definition. I hesitate to use this slide, but you do use it because I want to show you at the top there where it says 1 through 400, that's your root level of an index. An index can be a clustered index or non-clustered, and you can store it in a B-tree type structure. The actual data is stored down at the leaf level at the very bottom. So you have all the data for that index stored at the leaf level, and there's various ways it has to traverse to get down to, say, row 60 or item number 71. And I'm not going to go much more into that because it's beyond the scope of this brief presentation. Index create syntax. Normally, most people will use the prefix IX or IDX, underscore the table name, and underscore at least the first column name. And if you use that standard, that pretty well lets anybody else that comes after you look at it and say, well, what's going on? For example, in AdventureWorks 2012, which we're going to use for a lot of our examples, you could have index IX underscore sales order header, which is a table name, and then sales order ID, which is the column name. And sometimes some people will use CIDX for a clustered index where it's different than the primary key, or UIDX or UIX for unique, etc. Again, the primary key is created as a constraint, but it also creates an index with the same name. And there's an example of how you can create a primary key. The bottom line here, the drop exists in online on. Online on and data compression equal row is only valid for enterprise version unless you're running 2016 Service Pack 1. And online on is still not available even in the standard edition, just the data compression is. We'll talk about data compression a little bit later. So what are some of the attributes we have of indexes? Well, a composite index is more than one column to define the index. A unique index is an index that ensures the uniqueness of each value in the index columns. Primary key doesn't have to be the clustered index. Yet, one thing that's different, and this is a good interview question, is different that unique non-clustered indexes can have one row value of null. In other words, somebody will say, well, what's the difference between a primary key and a unique non-clustered index? And the answer is that you can have one row of null and a unique index. And the query optimizer takes advantage of uniqueness. So if you have an opportunity to define a non-clustered index that's unique, do it. It really helps with the optimizer. And then lastly, and we're going to go through several examples of this, covered index contains all the columns necessary to produce a particular query result. Things to think about when you're designing your clustered index. The wider your clustered index, the wider all the non-clustered indexes are on that table, because that's how the non-clustered indexes point back to the data. They go back to the clustered index key. So the wider your clustered index is, it takes more storage space, more I/O, not only for your clustered index, but also for your non-clustered indexes. So I try to keep clustered and non-clustered index data types to N or big N, date, time, and or small strings. Anything else just starts to become unwieldy in the size. Okay, so the optimizer takes advantage of indexes, otherwise we wouldn't be using them. There are three basic ways it searches for query resolution. You can have a table scan, maybe expensive, and table scan means it's going to go through every row of the table. They're expensive. Sometimes they're the only way to resolve a query. We'll look at an example of that. And it may also cause an encounter with updates where you get a scan. So it's just not for select statements. You can also get scans and DML type operations. You have index searches where now it says, like my example earlier where I said you have an index on last name and you look up Bird, it's pages 5, 10, and 15. So now it knows exactly where to go to pick up those pages. Index searches look at the where clause and the join clauses and gives back an estimate of rows and pages to return and whether or not it's going to use that index or not. Again, as I said earlier, covered index searches that contains all the data columns for that table in the index, including with your include clause. But be wary of Microsoft index recommendations. They tend to replicate or closely duplicate existing indexes that are already in the system. And we'll talk a little bit about that also. Whoops, wrong direction. Okay, let's go to demos. Come on. There. Okay, we're going to be using AdventureWorks. I just refreshed it there. And my first example is just a heap example. And this heap example, if you look at it closely, it's an exact duplicate in AdventureWorks of the sales.currency table. If we execute this, it creates the table. And you can see nowhere in there have I said anything about a primary key or a clustered index. So we can insert data just directly into a heap from, I said it's a duplicate of sales.currency, so we'll do that. And you get 105 rows affected. So if you come over to Object Explorer and let's do a refresh in AdventureWorks 2012, we have now down here under, here's our heap example. If we expand that, look at columns, it gives the columns, but nowhere in here does it indicate any kind of primary key. Likewise under keys and likewise under indexes, nothing's there. So that's truly a heap. There's nothing there that we have that's addressable for us to uniquely define a row. So if we do a SP help on that, again, and I don't know if you're familiar with the syntax with SP help, and you might become available, but nowhere in here does it identify anything that's a primary key. Unlike where if we go down to I'm sorry, my fingers are, unlike if we do a SP help on sales.currency, we can see here that there is a primary key, it's clustered unique primary key, and again it defines the primary key there, and it also references some foreign keys. So that's a heap in itself. Again, I rarely use heaps. I really like to be able to address rows. There's all kinds of ways you can define the primary key. One of them is to define it when you define the table itself. And you notice down here, I had the 3 rows like we had in the heap example, but now I have a constraint where I say PK underscore currency underscore currency code is the primary key clustered. The clustered as default is not really necessary, but let's go ahead and create that. If we come back over and refresh, we now have a PK example. And now note that it does say primary key for currency code. Likewise, we now have the primary key under the currency code there, and likewise it created the index PK currency code, and notice it said it's clustered. Okay, that's one way we can create a primary key. Another option is we just define it on the fly as we define the table. And you can see here under currency code, the primary key clustered, no name there or anything. So if I execute this and come back over here to Object Explorer, and let's refresh the table. It's one feature I don't like about Management Studios, the refresh. Okay, so now we have PK example again. Okay, currency code is the primary key, but notice the name here. It gives this funny number out here, and this is assigned by Microsoft SQL Server, not by, and the same thing for the index, and notice it's clustered. And one thing neat about doing SQL Saturday presentations is you always get questions, and sometimes you don't necessarily know the answer to the question. And I always thought you could not define the name. And somebody once asked me, well, you can define the name when you define it on the fly like this. And that's option 2. Option 2B is, notice up here, I enter the currency code, I have the constraint, and I give it the name, and I say it's the primary key. So if we execute that, come back over, refresh, and PK example. Okay, I have my primary key, and now the name that I put in there, PK underscore currency underscore code, is there as well as the index, so you can define it. And then the last way and frequently this is the way Microsoft does it when you right click a table and it does it, is it'll go through and add the constraint after it's created the table. So let's just first run the table right here. And we got that. So we come back over here. Come on, refresh. And we expand it. Notice there's no primary key, there's no key, and there's no index. So we created the table, but we hadn't. So in a separate T-SQL statement, we can add the primary key back in, so you can do it after the fact and refresh. And this sounds trivial, but I think it's important you really understand that this can happen. So there we have a primary key on currency code. We have our primary key, and the index was created. And notice it's clustered. Okay, so that's that. Okay, let's get into some of the, okay, so we can insert then into the primary key the stuff from that we had data. Notice it goes right in. And if we do a SP help on PK example, notice down here towards the bottom, it defines that we do have a primary key and we have a primary key cluster. Notice we did not have that when we did the heap example. So let's do some cleanup. Now let's get into the fun part. Let's look at non-clustered indexes. Okay, I usually, when I create a cluster, I mean, you can use the drop existent equal on if it's there, but then you have to have an if clause to figure out if it's there. So I usually typically drop it, then I recreate an index when I do it. I rarely, okay, so here's the syntax. Create non-clustered index, and non-clustered is optional. Use IX underscore, the table name and the column name on sales.sales order header, there's the table name, and salesperson ID, there's the column name. And on equal on, data compression equal row. And as I said, it's only data compression is only available in the developer enterprise versions along with online. However, data compression has now just become recently available on 2016 Service Pack 1. So rarely, and this is just for demo purposes only, do I create a single column index, because normally the optimizer won't use them, because usually your tables are asking for more information than just that column name there. So we create the index. Now, okay, so we have an index on salesperson ID. So I'm going to run a query, select sales order, account number, customer ID from sales.sales order header, where the salesperson ID is equal to 277, order by 1. Okay, let me turn on the execution plan. And for those of you that have never used set statistics, IO on time is sort of like a poor man's profiler. I use it all the time for performance tuning, because IO will tell you the number of logical reads and time will tell you the number of CPU milliseconds. So if we run this, we get 473 rows, and notice what the query plan is showing. It's showing that we used a clustered index scan. It did not use this index right here. And you go, well, that's interesting. Why didn't it use that? Okay, so if we do a right, or if we just hover over it, we can see the query cost is about 0.545. And if we come over here messages, we can see it did 689 logical reads. And so that's probably not very good performance. But let's look at another example. And all I'm going to do in the other example is I'm going to change what the sales person ID is. And you can see the answer right there. And now I get 16 rows. If we look at the execution plan, we have index seek, and it is looking at the sales order header salesperson ID table, but then we're doing a key lookup. And you're going, oh, why did it give a different query plan for what looked like the same query, only difference being what the salesperson ID was? And the reason being is, and if we come over here, we look now, the query cost is 0.05. It's a factor of 10%, or it's 90% less than it was earlier. And if we come to messages, we can see we only did 50 logical reads. So what the optimizer is doing is it's taking advantage of statistics to say, well, for a salesperson ID of 277, I'm going to return too much. I might as well just do a scan of the whole clustered index and get the data that way, because I'm getting out of that, I'm getting account number and customer ID. Sales order ID already is the primary key, if you recollect or if you're familiar with it. But down here under, where'd it go? Yeah, on this one here, it didn't use statistics. It said, well, I can go ahead and do an index seek and then for 16 rows and then look up the data I need out of the sales order header table for those 16 rows to get it. And that's a lot cheaper. Now, this, you run into sometimes this in stored procedures when your query plan keeps changing depending on the data SKU of your data. But there is a way to do it. And why the difference in query plans is just because of the size of the result set that's done. Non-clustered index selection tends to be more effective if less than 5% of the data is being accessed. Microsoft says it's 20%, but they have, under the covers, they have some number out there that it just seems like it comes out if less than 5% is to be exceeded. But how can we get an index to work for both things? So that's what a covered index does. And what a covered index does is it takes into account the columns. Look up here at the query. Okay, sales order ID is already in the index because that's part of the cluster ID. Account number and customer ID is not, and we'll create an index on search. So if we go back and redefine our salesperson ID index and now use the include statement for account number and customer ID, let's see what happens when we do this. And now I hope that covered indexes kind of makes sense to you when you see what happens next. Okay, let's rerun the first query that we had before. We still get 473 rows, but look at the execution plan. We did an index seek. Look at the cost of the query plan. Now it's 1% of the original cost. It's 0.005. If we come up here and look at the logical reads, we only had 5. Remember, it's a very large number before. Okay, so that index helped that particular query. And now if we come back and do the same query where we only had 16 rows returned, look at the execution plan. It's still doing an index seek on our sales order header salesperson ID table, and only use 3 logical reads. And if we come back to the execution plan, you can see it's still 0.005. So I hope the idea of covered indexes now kind of makes sense, but you got to be careful with covered indexes. You don't want to create the whole table. I just ran into that earlier this morning working for a client that Microsoft was suggesting an index, covered index, but it essentially reproduced the whole table, just sorted differently. And that's something you don't want to do because that takes up storage and also DML operations. So let's look at an example of a suggested index. Okay, so here's, again, on a sales order header, I'm asking for sales order ID, revision number, territory ID, modified date, where modified date is. And if you look at the execution plan, it gives the suggested index. If we right click and then say, show the missing index details, it'll go to a new screen and give you what it has. I already have this, let's get rid of that. I already have what it suggested here. Okay, so we have a query cost of 0.545 and we have 689 logical reads. for that particular query. And it's suggesting, this is the index it's suggesting. It's suggesting an index on sales order header that's on modified date, but it includes sales order ID, revision number, and territory ID. If you remember earlier, I said that all non-unclustered indexes have hidden under covers the clustered index primary key. So in this case, sales order ID is really not needed, even though Microsoft said it should be needed. So let's go ahead and create a index on modified date where we have modified date, but let's include the revision number and territory ID. In other words, we're going to cover it because that's what the query was asking. And you ask, well, where does this data get stored? The revision number and territory ID gets stored down at the leaf level. So if you have too many columns, your leafs become big and makes it very much more harder for Microsoft to negotiate the B tree. So if we run that, and now we rerun the same query that we ran earlier. Look at our execution plan. We're doing index seek. Seeks are normally good. And if we look over here, we have only 33 logical reads rather than 600, and I think it was 89. And if we come back over here, and the query cost now is 0.03 or 0.038 or so. Yeah. So this is where I would usually look out the audience to see if anybody's awake or have questions now. Okay, there is a way where you can actually compare the queries and the query plans together at the same time, and there is a command drop clean buffers. You got to do a checkpoint in front of it to clean out any data that hasn't been written out yet. I'm going to run the first query with the index, and then the second one, I'm going to say don't use the non-clustered index, use the primary key index. So you can run this. Oh, by the way, never use drop clean buffers on a production machine. Otherwise, you spend the next 6 to 24 hours rebuilding all the things that should be in buffer plan that don't. Okay, so the first query uses index seek. The second one uses an index scan. You can look at the query cost is 7% versus 93% between the two queries. However, the original, there's our 0.038, and here's our 0.545. So that is a way you can test to see whether an index is really helping you or not. I don't go so much credibility with the 7% or the query plan cost as I do with the logical reads and the time to execute the CPU time. Again, we have the 689 reads, and even though it's the same CPU time, if it's a bigger result set, you would get different numbers. All right, so let's see, where do we want to go from here? Okay, so it's an example where a query has to do a table scan. You say, shucks. Okay, what am I asking here? So I'm joining on 3 tables, and I'm saying where the last name is like, and I have the wildcard character, B, and the wildcard character. So that means give me any last name that has a B in front of it. It's impossible to create an index for this because what column is the B going to be in? And so if we look at the execution plan here, it's asking for an index, but notice that it's doing a index scan, and it's actually using person underscore last name, which this is last name is coming out of the person table, but it's doing a scan of that index because it doesn't know where the B's are. Now, and that's what we call a very non-selective. There's no index that's ever going to solve that problem. But you can, if you're asked a slightly different question, if you could say, give me all the rows that have, where the last name starts with a B, and run that. Notice the execution plan here. Now we do an index seek. So it is doing a seek on the same index rather than a scan, but now I can do it because now I can go straight to and find out, well, what last names start with the letter B. And that's how it does its seek. So that's one way. There's another instance where you will always get a table scan. If you do up here a select star, it's going to be like clustered index anyway, because you're asking for every column in the table with the select star. Okay, so if you look back at my query here, I have a query that's from sales.salesorderheader, join on sales.customer, and join on person.person. And if we look down here, come on, grab. I'm going to sales order header and I'm joining the cluster customer, and I join into person, and I got matches. So I have the create on sales.customer. So it's suggesting this index. So even if I add the index, let's go ahead and add the index that it asked for. And so if we run the same query where we're looking for all first names with B, I'm still getting index seek, but now it's using the index that it asked for that we created up here under customer person ID. So it's a scan, but now it's a scan of a non-clustered index, which hopefully it's going to be smaller and less pages than the previous one. Okay, so let's clean up some. Let's look at a just look at a query and see, well, what are we really asking for here? And this is sort of how, when I write a query, I look at it from a slightly different organization than when I execute it. Okay, so what information are we asking for? So the information is up in the select statement, and that's going to define what tables we need to hit. You can see P is the alias for sales for person, H is the alias for sales order header, D is the first sales order detail. So if we look at these, and then we look down, and H comes out of order date, and we look at it, and so the sales order, we're asking for these columns, and these columns include whether in the select statement or the join statement. Same thing here, business entity ID. So what indexes are really needed? So if you first you need to check see if the index already exists. If it already exists, then maybe you don't need to add it. Or for one that's very close to it, then look at that and see if you can make it a covered index that serves two queries as opposed to one. Okay, so let's run this query. And let's look at the execution plan here. It's still asking for something on sales order, but okay, so we have a index scan on product and or on product name. That's coming out of product table. Where's product? And there's product right there. We have sales order header. There's sales order header there. We have person, and then we have sales order detail. Notice nowhere is customer showing up here. Anybody have any idea? Anybody have any ideas why customer's not showing up? Okay, I'm not going to create that one right now, but so why isn't it? We'll come back to that in a second. And then we'll go ahead and create the two indexes that it's suggested. And if we rejoin again, same query that we ran earlier, only now it has the two indexes. It doesn't index. Okay, we created an index on sales order header and one on sales order detail. And there's the index on sales order header. There's person, sales order detail. It's still doing a clustered index. Sometimes, even though Microsoft might suggest a index, it doesn't use it. In this case, it did not use it. This is why when you're either writing a new stored procedure or a query, that you go back and look at it and see, well, what's being used and what's not being used. But it's still, if you look through this entire query, there's no join to the customer table, even though we have a join to the customer table right there. And the reason being, well, why is there cost? Okay, the reason being, and I have another briefing I do on foreign keys, but let's just look at sys.foreign keys. If you come over here, you have two primary columns that are very important: is disabled and is not trusted. And notice these are negative. Zeros means that it is trusted. 0 means that it is enabled. So if you have, and then, all right, so it still doesn't quite explain, but if you have a customer or you have a foreign key reference and you're not asking, notice nothing up here in the select statement, nothing in the on clause, and nothing on the or the where clause is asking for anything out of the customer table, the optimizer is smart enough to say, well, I know everything is proper, it's trusted, so I'm just not gonna, I don't have to worry about it. And that is the reason why you have that. Okay, so this is let's go back and I want to run one more example for missing queries. We'll go back to the briefing, then we'll come back to a couple more demos right after that. Okay, consider these three queries. Control R. Okay, we have select star from sales order table where person ID is 711. We have select sales order ID, carrier tracker number, modified date, and then we have select sales order detail, order quantity, and modified date. So these second and third queries are not quite the same, but we're asking them all for the same product ID. And if we execute them once, and that executes, and this is a query, if you write me, it'll be in the demo 2 script. It's a missing index query. You can Google it and you can find it out in the world. There are no missing indexes. Okay, so you just run something once, it doesn't show up. But something I learned somewhere, that if you put a number after a go statement, it'll execute it that many times. So if we execute those same 3 statements 12 times, and it should finish up, it's finished. Now we run the missing query index, query. There's 3 indexes that it's asking for. Notice it gives you the create statement also. And rather than me copy these down, I've already copied them down for you and create the index. Here's what it's asking for. Notice that okay, so the question is now, we could probably write a cover and index for queries 2 and 3, but do we really want to write a covered index for query 1? Because what is query 1 asking for? It's asking for every column in sales order detail. So these are the 3 queries it's asking for, but we really don't want to, I don't think it's too wide. Unless you're running this 100 times every hour, then you probably don't want to reorder and have a duplicate table sitting out there just reordered a different way. So we can do something with the original indexes 2 and 3. We can actually cover them, and we can write a covered index. And the difference to remember is that up here, the only difference is modified dates common between them, and sales order. That's part of the primary key, and that's part of the primary key. So the only really differences are carrier tracker number, order quantity. And if you come back down and let's create one index, it has carrier tracker number, modified date, and order quantity, and run that. And now if we run the 3 together, okay, so the execution plan, it still wants that missing index, but I decided I'm not going to do it. And look at the cost here. The overall cost is 97% compared to 1%, 1% for the other 2 quantities. And notice down here in the second and third, come on, second, third, it's using the index seek. So it is using it. So, you know, at times you got to make trade-offs. Are you going to cover or not cover? And if you are going to cover, how wide is the cover going to be in it? And I have some recommendations to that coming up in just a second in my brief. And I think that's the end. So let's switch back. And I got, looks like 13 minutes and we're running. Okay, so let's talk about what we just seen. Databases and indexes. In OLTP systems, transaction processing systems, you want the writes to be fast. Few indexes is needed and less is good. Narrow indexes, and that both includes your index definition and your include clause. My rule of thumb is for OLTP system, a max of 6 to 8 non-clustered indexes per table, but only if needed. And there are occasions where I have exceeded that just because I had to, mainly because the client would not come up with the data warehouse and was doing reporting out of the OLTP system. On OLAP, the reads need to be fast, and so you probably need more indexes to support your queries and aggregation, and obviously probably wider indexes in the data warehouse. My rule of thumb here is about 18 to 20 non-clustered indexes. Less is still good. Be careful of width, and if you only need 8 indexes for data warehouse, just stay with that. I mean, those are just rules of thumb. Okay, for existing indexes, I'm going to show you a query that looks at existing indexes to see if they're utilized or not. You can look at SSMS under table to figure out indexes. You can script out all the indexes via Management Studio under the database under generate scripts, advanced scripting options, or you can actually script them out yourself using sysindexes and sysindex columns. I'm not going to talk much about it, but why would you rebuild indexes? As you do inserts and updates, chances are you may be causing pages to fragment, and when they fragment, they get essentially out of sequence. And so if you rebuild, typically you can increase your I/O performance. It will cost blocking, or it may cost blocking, sometimes deadlocks, because it puts a schema lock on the table while you're rebuilding indexes. The enterprise version allows online rebuilds, but even with an online rebuild, if you have a table with large objects like XML or varchar max columns, you're still going to get schema locks. And there's some discussion in the community of whether just do rebuilding only or rebuilding versus reorganizing and when to do it. And definitely in the cloud, probably you're going to pay less if you just do rebuilds, not reorganize. And then there's unused indexes, and I have a script that I'll show you in a few seconds for that. Consider disabling the index, and you can disable it by just right-clicking the index name and hitting disable. And that keeps the definition there for a while, and it doesn't do any inserts or anything. Remember, on an unused index, the script only gives you what has been used since the last restart of SQL Server. If you have some reports that use indexes that only run monthly or quarterly, you make sure that you include those. You can always re-enable a disabled index by rebuilding it. And then be missing indexes. We've talked some about this already. Be wary of what Microsoft recommends. Microsoft recommends all tables in a heap in their recommendation. They also include clustered index columns. Watch and see if they duplicate something that already exists. If they duplicate something that already exists, then look to see if you can cover and make cover index cover one or more queries. And again, the whole time though, you just have to be wary of index width and duplication. Okay, let's look at, I'm not going to do demo 2, but I am going to show you the scripts that are there. Demo 2 is here. Their index usage will give you all the indexes that have been used and not used since the last restart. So the unused indexes, this is sort of a revised version of the one above. This gives you all the data for how the indexes were used. This gives you ones that's just not used. And they're not used meaning that there's never been a read from them. Missing index, I already showed you that earlier. It's there. And then you have a script to remove hypothetical indexes that are left over from the tuning wizard, as well as hypothetical statistics left over from the tuners. I'm not going to go through these. We don't have the time. But let's go to demo 3, because I like demo 3. A lot of people talk about, okay, it costs you when you do DML operations to have indexes. Well, what does it do? This is a query I use out of AdventureWorks. I'm not going to run it, but I'm going to come up here and I'm going to do a query and I'm going to display the execution plan. And what I want you to look at is, look, okay, so there's the index. There's an index there that's being insert it into. There's an index there. It's the same one. Come on. Other indexes, there's your PK. And other indexes you can see down here. So when you do an insert, you're not just inserting into your clustered index, you're also maybe inserting into your non-clustered indexes. Let's look at what happens if you do an update. And Control L will give you an estimated query plan. And it really doesn't show you anything about indexes, but let's right-click this and show the execution plan XML. Come back over here and let's do a search on one of the indexes that exists for that table. And if we come back over here and do Control F and backspace, Control V, notice not only are you touching the primary key, but you're touching the other three indexes that belong to sales order header. And that's just from an update. Delete, yeah, almost the same thing. Control L. And how are we doing time-wise? We got 7 minutes. We are doing perfect time-wise. All right, so again, you don't really see much in the way of indexes here. You see a couple, but if you right-click and you show the execution plan, and then you do Control F to find, and you can see, look at all the indexes that are being touched in that delete. So a delete just doesn't touch the primary key, it also touches all the other indexes that belong to that table. So let's go back over to there, and then I talk a little bit about demos 2 and 3. Okay, indexes. I hope you know a little bit more about them. I hope you appreciate when they should be used, not used. They can help when you have an appropriate clustered index and stores, and it can help when you have narrow non-clustered indexes that satisfy the where clause. And I probably didn't talk enough about that. And I'm welcome for questions in that regard. And then we talked about included columns where you may have a covered index. And they really only work when the statistics are updated. If the statistics are out of date, no telling what you're going to get. I talked a little bit about index compression, and I can see no reason, if you have the enterprise version or you have Service Pack 1 in 2016 for standard edition, to not use row compression equal, or data compression equal row. It cost, the logical reads goes down phenomenally, and this is, I have not found an example where it hasn't gone down, and your CPU usage just goes up a little bit. I mean, it's not enough to, if that little bit of CPU usage hurts you that much, then you probably got the wrong hardware, or you have a lot of queries that are bad. Anyway, there's just no reason not to use row compression if you have it available. Indexes can hurt. You can have too many on a tables that are frequently updated. You can have duplicate or near duplicate indexes. I found some clients I've walked into that I've never been at before. They used every index that Microsoft recommended, and they had near duplicate indexes out the kazoo. Just couldn't believe how much. Okay, not enough key columns, not in the right order for your indexes. Sometimes there's not included columns, or not enough, and too many. Again, if it's too many, it's probably going to make the index too wide. When an index does exist, but the query is non-selective, and can't use it. And we saw an example of that earlier. And statistics are out of date. SQL Server just can't build a good plan. Can't live with them. Can't hardly live without them. Need to be really careful on size, near duplication test, and test in your development environment. And I sat in on a very good index webinar by Jeffrey Garbus at the end of January. I don't know how to address it, and I can't find it, but it was very comprehensive, and so you could do he blogs, so maybe he do a Google on him, and goes to slightly more detail in some areas. And I have talked about, I show more demos, he talks more about how to optimize your use. Google, there's lots of great examples out there. Just remember though, a great index performer booster for one query may not work for another. And I'm unabashedly talking about, and Julie talked about the SQL Saturday in Phoenix. I'll be there. I have a presentation on in-memory tables, and I also have a presentation I'm giving on in-memory indexes, and that'll include hash indexes, non-clustered indexes, and column store indexes. I appreciate you staying with me, and I'm definitely open for questions. Julie?
Okay, we've got quite a few questions that have been posted. One was right towards the beginning, and they wanted to get a better understanding of the difference between the primary key and a clustered index.
Well, normally you use them the same. The only time I've actually broken them out is when I've been doing partition tables. And even that has some drawbacks there, or you can also use partition. But the difference is that it is really normally you're going to be one and the same, and I'm not sure how to explain it any better than that. The only time where I had to break it out is where I had an existing table already in existence, and I wanted to partition a month, so I added I kept the primary key as the original identity column and added a second column of a create date key, which is an integer form, year, month, day, and made that so I could partition then the data within that table. That's the only example I can think of, and I'm not sure that answers the question, but that's the best I can do for now.
I've had it where, you know, a primary key denotes uniqueness, but you don't necessarily have to have the data ordered or clustered by it. It could be the majority of the time the queries are going after the data in a different order, where you may have a non-clustered index created, because that's how the majority of the people need to go after the data, but it's not unique, so you still need that primary key.
Right.
A few people wanted to thank you for your service to the country.
Thank you.
And then there were quite a few comments about they were still awake when you asked if they were awake. What happens when you don't have a clustered index for a table and only have non-clustering indexes? Is a row ID lookup less efficient?
That's a very good question, and it's one I haven't explored. It depends on how your data is ordered and how you want to access it. Because remember, in a heap, if you don't have a clustered index, you don't know what the order is, and you really don't know how SQL Server is storing it. It's stored in a B tree just like the others. It's just not stored where we can see it. So I think it depends on the order of the data and how many IOs are represented. I can think of examples both directions where performance would be better. And I don't have enough time to go into those right now, but I would love to do that offline with anybody that wants to.
So does the drop clean buffers wipe out the statistic information?
Drop clean buffers wipes out your buffer cache. So if anybody that's ever started with a clean version of SQL Server and in production, notice that the performance wasn't very good the first anywhere from 6 to 24 hours, and it's because the buffer cache really hadn't got established yet as to what needs to stay in there and what doesn't need to stay in there. So does it wipe out statistics? No, I don't think it does. But that's a educated guess. I don't think it does.
Okay. You know, when you're doing the execution plan, you showed query cost, but they had a question about what does query cost mean? Is it time saved, or how does it really help in a real world system? Is it only something that you use in development? And I've always learned that the query cost is just a relative term. I don't know. What's your take, Mike?
Yeah, my take on query costs, and I use it as a relative term. I have actually seen written queries where the query, one query versus the same query but written slightly different, where the query cost for query A was like 70% and the query cost for query B was 30%, but query A ran faster. Query cost is a number that Microsoft comes up with that they won't tell anybody except the MVPs what it really is under the covers there, but it's an indication of utilization of resources. Excuse me. It's an indication of resources and that are used, and that includes I/O as well as CPU time and maybe some other things. I don't know. So I really, when I'm performance tuning, I really use the set statistics ION, and I use the logical reads there, and I use the CPU time in milliseconds, because that is the most accurate of what's going on. And I don't know how to say it any better than that.
Any recommendations on index filter factor with your experience? Do teams have a standard, or is it something that falls under the it depends?
I don't have a standard. That depends is very good. I mean, if you're looking at a database, so you need to determine how many updates are going to be used. I mean, and really the size of your data. And if there's going to be a lot of updates, which is going to cause fragmentation, then obviously I'm going to drop my fill factor down so I don't hopefully have as much fragmentation. I think the gentleman or lady that asked the question says that depends. It really does depend on the scenario that you're looking at. If it's a table that's rarely updated, then I'm going to use a large fill factor. I may use 100.
If you have a wide covering index, does it which serves multiple purposes, would you split it out into separate covering indexes?
That's a good question, and I don't have a rule of thumb there other than the rule of thumbs that I had talked about earlier in my presentation. If it's a data warehouse and it's wide, I'm not going to worry about it near as much if it's an OLTP system. I really work, because OLTP really need to get those writes in the system. You need to get them in without having to wait for locks and latches to go away to be able to do that. So I would, right now, without knowing the specifics of that particular scenario, I'd probably lean more towards 1 wide rather than 3 narrow.
Let's say we have an index on column 1 and column 2. If I run a query that filters by just column 2, will the query use the index?
Okay, say that again.
Sure. They have an index on column 1 and column 2, but the query filters by column 2, and they didn't know if it would use the index. And
I don't know, but now you gave me an idea to go try something and see if it works. It's very easy to test.
It depends. You know, it may choose to do index scan.
Right, because the data in column 2 is sorted, but it's sorted after column 1 is sorted.
Right.
Anything else?
Oh yeah, I'm just getting through the list. In the case of an insert which is taking too much time, what can be the reason? Does the index, I guess, can indexes have an impact? I think you addressed that in the lecture. It's a balance.
It's a trade-off. I mean, not only do you have foreign or indexes can hurt insert performance, but foreign keys can hurt insert performance too. If it's a large data insert, then I'll probably turn off the indexes and foreign keys and then rebuild them after the fact. And by large again, that depends. But if my inserts are taking too long, usually it's either from an index or foreign key issue.
And then another person followed up asking, does the order still have an effect of whether an index is used? Yes, the order of the columns, yes.
Yes.
Let's see.
When I pick an index, the leading column I really work hard to make it highly selective. If the leading column is gender and your only choices are M or F, then it's not very selective, and rarely will I even use that as an index. I'll really look at something else to see, is there something else in the queries using that index that's more selective than gender.
They're asking for you to put your email contact information. This is being recorded, and Mike, if you wanted to also send me your slide deck, I could post that as well, and if you wanted to send me a zip with the scripts, I can post that on the user group archive webpage.
I'll send out or Julie will get the slide deck and all the demo scripts, and there's my email address right now on the screen, and also my website. You can get email to me through the website also.
So how do you determine the order of the columns in the index? Also, if it makes a huge difference if a column is part of a non-clustered index or included.
Okay, that's really two questions.
Yep.
One, as I said earlier, the order is I look to see what's the most selective. Again, gender to me is not very selective. So I really go with selectivity because that really determines how the optimizers are going to, whether it's going to use the index and also whether it's or not use it. Now on the include, okay, if you remember in a B tree, the primary key is traced all the way down through every level in that tree. So the smaller it is, the more you can fit into each page that is traversing down the tree. So I really work at pushing stuff to the include clause because that's only down at the leaf level. It's not in it's not in any of the intermediate nodes. So I try to keep that first or second column in the primary key is very selective, and after that I just throw it to the include column. Again, that's because of size.
What's the difference between seek and lookup?
Okay, so seek is where it finds all the data in the index and it doesn't have to do, it finds all the data in the index. A lookup will be where it uses an index, but say the index has columns A, B, C, and D in it, but doesn't have column E. So it will have to go back and do a lookup out of the clustered index for column E to get all the data necessary for that query. I think that answers it. That's essentially what it is that the original index did not cover or have all the information that was necessary for the query to complete.
So the next one, I'm not sure if it really pertains because this is about indexes, but it's asking in a stored procedure, which one is better to use, a table variable or a temp table to improve the performance, including dynamics queries?
Well, this is a personal preference by Mike Bird, but I like the temp table better because I can put indexes on it, and the table variable I rarely use unless I'm going to pass an array into a stored procedure. The table variable, the optimizer thinks it's a heap. Oh, it thinks it's a heap, and also thinks that even if you define a primary key for it, not only does it think it's a heap, but it only thinks it has one row of data. So if you have a table variable that has 100,000 rows in it, and the optimizer thinks it only has one row, then you're not going to get a very good query plan.
Quite a few people, and thank you again for the very interesting presentation. And that's it for the questions. So this is recorded. It will be posted on the DBA Virtual Chapter Archive page. And Mike has his information up here. You can send him emails. And Mike, I'll send you along the question list.
Okay. All right. Thank you again. And I enjoyed doing this, and I hope you learned something today.
Thank you very much. It was a very good presentation and very well received.